when I'm taking a limit of a complex fraction. Why do I call this a complex fraction? Because I can put this over 1. When I do that and I put in my 0, I get 2 over 0 plus 6 minus 1/3 over 0 over 1, which simplifies to 0 over 0. Remember, we call that an indeterminate form, so I better have a plan B. With this type of problem, my plan B will be to combine the fraction and then cancel. Notice what I'm doing here is I am going to find the common denominator of 3 and x plus 6, which of course is 3 times x plus 6. And then I'm asking myself, well, x plus 6 times what gives me 3 times x plus 6? What's missing here is 3, but I can't just multiply the denominator by 3. I have to multiply by a fraction equal to 1. So 3 times 2 in the numerator is 6. And then I'm over here, and I've got to multiply this one. I'm just going to erase this a little bit to get our work in. I'm going to multiply this one. 3 times what is 3 times x plus 6? Of course, that's x plus 6. And I'm going to multiply by x plus 6 over x plus 6. Notice what this is. It says -1 times x plus 6, which is the opposite of x plus 6. Now I'm going to try to simplify. Limit x approaches 0. Well, if I distribute this -1 to both, I'm going to have 6 minus x minus 6 over 3 times x plus 6 over x over 1. And if these have been good little 6s, they go off to number heaven, which will leave me with limit x approaches 0 of the opposite of x over 3 times x plus 6 over x over 1. And now I'm going to use my keep, change, flip. This is limit x approaches 0. I'm keeping this numerator, -x over 3 times x plus 6. I'm changing division to multiplication, and I'm flipping this 1 over x. Notice, because this is multiplication here, we can cancel these. But if I do x over x, that's 1 over 1, or simply 1. So I essentially have -1 times 1 is limit x approaches 0. -1 times 1 is -1 over, this is 1 times 3 times x plus 6. So that's simply 3 times x plus 6. If you wanted to distribute and make this 3x plus 18, that's fine. What I'm going to do now is, after I cancel, I'm going to substitute in the 0 here. And this will give me -1 over 3 times 0 plus 6, which is -1 over 18. That is the limit. That is the trend in y. And we have a hole. Well, x is approaching 0, and this is where the y is heading. So bonus. This is not the answer, it's just a bonus. 0, -1 over 18 is the hole. We were trying to take a limit at the hole. We found that immediately. As soon as we got this indeterminate form, we know this IF means we had a hole. Where's the hole? When x approaches 0, y is heading towards -1 over 18. That's the limit. This is the answer. When I'm faced with a limit problem, of course, my first option, plan A, is always to use direct substitution. And when I do direct substitution, I get 1 over 4 minus 1 over 4 over 0, which of course gives me 0 over 0, which is an indeterminate form. And I know right away I have a hole. Where? As x approaches 0. Now a hole is an xy point. I'm not sure of the y coordinate yet. Because I have a complex fraction, there it is, a fraction over a fraction, I'm going to use the method combine fractions, then cancel, then use direct substitution. So I have the limit as x approaches 0 of, well, I have x over 1. So I'm going to keep that. I want the common denominator of 4 and 4 plus x. So I'm going to say 4 times x plus 4. And what I'm doing here is saying, well, x plus 4 times what gives me my common denominator? That's pretty easy. What's missing is 4. But I can't just multiply the denominator by 4. I have to multiply the numerator by 4 as well. And 4 times what gives us 4 times x plus 4? Of course, that's x plus 4. But I have to multiply the numerator by x plus 4 as well. And when I do this, I get 4 times 1 is 4. Now this is the opposite of 1, or negative 1 times x plus 4. The next thing I do is I'll simplify by distributing to give me the equivalent limit x approaches 0 of 4 minus x minus 4 over 4 times x plus 4 over x over 1. Now what I'll do here is I will simplify. If these have been good little 4s, they'll go off to number heaven, and we're left with the limit as x approaches 0 of the opposite of x over 4 times x plus 4 over x over 1. And now it's time for me to keep, change, flip. I'm going to keep this fraction, change division to multiplication, and then flip this. Negative x over 4 times x plus 4 times 1 over x. Because I have multiplication here, I can cancel these off. Remember, when you cancel, you have a whole. Set whatever you cancel equal to 0. Well, x equals 0. We knew that because x is already approaching 0. The opposite of 1 times 1 is negative 1 over 4 times x plus 4 times 1. These cancel to 1 over 1. X over x is 1 over 1. So this is 4 times x plus 4. And I'm going to take the limit of that as x approaches 0. Now I'm ready for this direct substitution. If I take the limit of this as x approaches 0 here, now I can use direct substitution. 1 over 4 times 0 plus 4, of course, gives us negative 1 over 16. And there is the limit. The limit is the y value. I knew I had a whole. Well, here, this told me I had a whole at x equals 0 because I take whatever I cancel and set it equal to 0. And I also knew as x approaches 0, y is approaching negative 1 over 16. So here's our bonus material. Where's the whole? There's the whole. That's not the answer. The y coordinate of the whole in this case is the answer because we were taking a limit right at the whole. By the way, I got a question in class. What about this? Isn't there a whole at x equals negative 4? No. Remember, when we take this surviving function after we cancel and we set the denominator equal to 0, that's where we have a vertical asymptote. The vertical asymptote would be found at x plus 4 equals 0. So x equals negative 4. When I set this denominator equals 0, and then I divide both sides by 4, I'll wind up with x plus 4 equals 0. So that's a vertical asymptote, not a whole.